Welcome to a deep dive with Java Records. Click on here. Quick word of introduction. As you saw in the meetup, my name is Jason Young. I'm a co-organizer of the Philly JUG. You can find me online on Twitter. And like me on Twitter, you can find all the code that we're going to see online. We're going to see a lot of code tonight. So I think a good way to learn how code works is to work with a lot of code. So everything you see tonight is available on GitHub, and there's a link right there. So without any further ado, let's dive in. So consider the humble int. It's easy to declare with one line. You can pass it into a method. You can return it from a method. Everyone loves a good int, right? The classic data structure. Now let's say I want to do something simple. I just want to go from one int to two ints. All of a sudden, the complexity of the code I have to write just explodes. As you can see here on the slide, I declare a class, I have member variables, constructor, accessor methods, and if I don't hate myself or my coworkers, equals hash code and toString. So a lot of work to just go from one int to two ints. But what if I told you there's a better way? The Java record is a new language syntax introduced in Java 14 and finalized in Java 16. And this line that you see right here completely replaces all of that code that we just saw on the previous slide. So we have a new word here, record, and then here, this is our example record, or you could think of it as a class. Our record name is point. These are called record components. This is what the constructor will look like. And there are open and close braces. You can add methods and do things that you want inside of here, but you don't have to. The Java runtime will generate all those methods for you. It'll generate the constructor, the accessors, and the equals and hash code and toString for you. So you might say, hey, Jason, that's great. Now we all know what a record is. We can all go home, right? It would be nice if it was that easy, but I think that there are a lot of things we can do with it. And the goal of this talk is to guide you in directions where they're really useful and practical, and maybe guide you away from the edges where they are not really intended to be used, so that when you take this into your own work, you can find it immediately useful and practical. So now that we all know what records are, let's talk about the motivation for records. By the way, I have the screen that I can see everyone else on is minimized so that I can see my own slides. If you have a question, Jeannie, you can just interrupt me, just speak up, because I won't be able to see any signals from the screen. All right, so let's talk about the motivation for records. So you might say that it's a goal to get rid of all that boilerplate code in the beginning, right? You replace all this code, dozens of lines, with a single line. But it's an explicit non-goal of Java records to eliminate boilerplate. The core concept of records is that if you give developers good semantics for modeling data, the boilerplate just naturally takes care of itself. So to that, you might say, well, Jason, I don't really care about boilerplate. I can push a button in my IDE and it will generate those methods for me. So that's fine. IDEs do help you write code, and that can be very useful. But the point of records isn't so much to help you write code. The point of records is to help you read code. If you look back at this class with all the boilerplate, you can't just tell at a glance that it's a pure data carrier. You have to read the entire thing to really figure that out. With this, you can tell at a glance exactly what this is supposed to do. So again, the point of a record is not to write code, the point is to read code. So you might also say, hey, I don't care about writing code and reading code. I use Lombok. I just put some annotations on, really easy to read. So some people love Lombok, and if you do, that's great. But the Java language designers don't want to lock you into using Lombok to take advantage of other language features. Java records are intended to work well with things like pattern matching and future language features like deconstruction. So Lombok won't necessarily fit in with those, but something that's built into the language will. So this is one of the motivations for records. So with all that aside, we know what records are, and we know some motivation about records. Let's dig in a little bit more to the details about how records work. One good way of telling how records work is to compare and contrast it with something we all know and love, the standard class. So how is a record like a class? Records can have static properties and static methods. You can add whatever constructors and methods you want. Records can implement interfaces, and you can put annotations on the record class and on the record components. You can even use generics. So a lot of the real day-to-day things that you would typically do with a class, you can also do with records. It makes it very easy to pick up and just start using them in your day-to-day work. But records are not exactly like classes. There are some key differences to be aware of. Like an enum, it always extends a core Java lang class, which in this case is Java lang record. And it cannot be subclassed. It is always a final class that's generated there. So it exists as it is. It's a pure data carrier, and that's it. And next, this is an important point. A Java record is not and cannot be a Java bean. It does not follow the Java bean convention. If you had a record component called item, the accessor method would not be getItem. It would be simply item. So it looks a little funny if you're used to the Java bean convention, but it does read a little bit better if you're using method references in a stream. And we'll see that in the code in a little bit. Next, records are strongly immutable. It is actually impossible to modify a record once constructed, even with reflection. And that's an important point, because if there is a third-party library that depends on reflection to modify an object, then you are going to have problems with that. So it's something to be aware of. Finally, something that you may be used to with classes is that if you don't provide a constructor, the runtime will automatically provide you with a no argument constructor. With records, however, they always only provide you a full argument constructor, the so-called canonical constructor. It takes all arguments. So if you want to know our constructor, you have to write it yourself. So those are some of the key differences between records and classes. So I think we have a lot of good details now. We're starting to build a mental model about how records work, and we're going to start to dig into some code here and see what this actually looks like. I have here a basic test. So you can see that I can declare it with record, class name, my record components, and an empty body. We don't have structural typing, so you can't, even though they have the same type and the same names, you can't just assign one to the other. You can, however, implement interfaces and assign one that uses interface to an interface. We'll see that in a little more detail. This is a new syntax. This is called the compact constructor. This is a simple block of code. It looks like a constructor, but you can see there are no constructor arguments right here where you would expect. This block is, however, called by the canonical constructor. So again, this is called the compact constructor, and it's intended for validation. So all of the arguments that are passed into the constructor are going to be available at this point in time, and you can do all the validation that you want in there. If I were to run this in the debugger, you'll see that I construct this object with an invalid value, and it's going to appropriately throw this exception. So it's impossible to construct an object that doesn't conform to this.
So Jason, let me interrupt for a second. There's a couple questions in there. I think you answered the first one already, which was, can we replace Lombok with records? But the second one just came in. Does this mean that records are not serializable?
That does not mean that at all. Records are very serializable, and we're going to do an explicit demo of just that. Is that all the questions?
That's it for now.
Okay.
Keep them coming, everyone.
All right, great. So let's talk about immutability. Records are shallowly immutable. So once constructed, you can't modify the record itself, but things that you passed into it could themselves still be modifiable. So if you wanted to do something like use an unmodifiable list, you can reassign it inside the constructor. Here I'm overriding the canonical constructor and assigning an unmodifiable list. If I were to step through this in the debugger, hopefully everyone can see this okay. Here we go. I'm going to pull this up a little bit. You can see here we have our array list. This is a mutable data structure. And once I construct this, I'll step over. Here's the record that I just built. Mutable words is the name of the, list is what I just built. So if I step into that in the debugger, you can see that I have an unmodifiable random access list for the words list that is inside of it. So I've just made this a strongly immutable, deeply immutable object. And if I were to try to modify that, like get a hold of the list and clear it, you can see that it would, of course, throw an exception as we would expect. All right, test passed. That's what I like to see. So with Java 14, 15, and 16, and the introduction of records, we have some new ways to declare things. Before, you could not declare an enum local to a method. So this was not legal before. With records, this is legal. And I know this is not explicitly record related, but it is part of the larger trend toward being able to declare things locally inside of a method. So you have an enum you can declare locally. In interface, you could not do this before, but now you can. And here I have records, enums, and interfaces all in one beautiful, albeit useless line to wrap this enum in my record. Also, this is maybe a little more of a side note, but for sake of completeness, we can also have an inner class that declares a member that's explicitly or implicitly static. So this was also illegal before Java 16, but now we can do it. So if you like doing metaprogramming and you like using reflection, you're in luck, because records give us some new features, new things to interrogate our classes about. Given an arbitrary class, we can tell if it is a record or not. So in this case, this is a record, and the enclosing class, the test class, is not a record. And once I have a reference to the class for the record, I can get its record components, which would include the number of components. You can see I have an array here of length 1, and I can see the type of the components. It's a string, and I can see the name of the record components. Here it's just component. So this gives me some facilities to do a sort of metaprogramming around records, if you like that kind of thing. I think I left my debugger running on those other methods. Okay. All right, so that's it for the basic tests. Before I get out of this, are there any other questions? Is there anything that we should look through the debugger with? Okay. So
I'm not seeing any new questions now.
Okay.
Okay.
So we have this this wonderful data carrying facility, and anytime you can carry data, you have to ask, how am I going to build up this data? So a standard way that we've built through the years is builders. I've used builders a lot myself with things like protobuf. So you might be surprised to hear that records do not have builders. I'm here to tell you that you might need builders less than you think. Mutability can hide code smells. It's easy to make something really convoluted because builders afford you the opportunity to build something like that. So you might be better served with a factory. But not to worry, future language changes are on the horizon, which will enable us to take maybe a generic or default record and perform transformations on it to accomplish the same things that you would traditionally use Builder for. That said, if you really want a builder, there are still ways to use a builder. When I was working with records myself, I found it useful to write a unit test, and I have a data structure. I want to change just one field so that I can test just one slightly different code path. Seems like a shame to throw away this record that I've already built, right? So you can write a builder method inside each record as needed. So you can be very targeted about what you're doing. You do have to write the code yourself, but it's pretty simple, and that's what we're going to see in the demo. There are third-party record builders. I'm not going to demo these, but I include links to these for completeness. So these are not Lombok. These are actually designed to work with Java records specifically, and they give you builders for Java records. So let's take a look at what a builder might look like if you were to try to implement it yourself. I'll open up a builder test. So I have here a record called a buildable person. As I've mentioned that you can do before, I made my own default constructor, an empty constructor that has default values. I have a static method that will build a new default object, and I write my own withers, which will take a value and return a brand new object with that value in the appropriate place. So if I were to step this through the debugger, you can see I'm building a record using my static method here that just gets me my default objects, call my withers, get this. And then I can use this object and call my wither again, and this creates a brand new object. These are two different objects where some of the data happens to have been the same. They're going to have the same last name in this case. So, and we can inspect these and say that these actually do look exactly like we would expect. So that's one way that you can get around builders, or the lack thereof, by just writing a few lines of code. All right, so because records are excellent data carriers, I would be amiss to talk about data carrying classes if we didn't talk about JSON and data transfer objects, or DTOs. So if you're using Jackson, particularly Jackson version 2.12 or greater, you're in luck. Everything works out of the box. It's pretty slick, no change necessary. It'll serialize and deserialize objects to and from JSON just as you would expect. If you're using a slightly older version of Jackson, it's pretty simple. It's not quite out of the box, but it's pretty easy to annotate your records with a Jackson annotation that will enable it to properly serialize and deserialize objects. This is what it would look like. If string X here is your record component, just add this one annotation on that one record component, and Jackson will be able to serialize and deserialize it properly. If
Jason, we have one question.
Okay.
How do records handle returning defensive copies of other objects in the getter method?
Defensive copies? You would probably want to do something like we saw a little bit ago with deep copies, or with deeply immutable objects. You can, I believe, override the accessor method, and you can modify what's being returned. I would probably caution against that and ask you to just make sure that what goes into it is immutable in the first place. Records are designed to be immutable objects, so anything that returns I would expect to also be immutable. I'm not sure of the exact use case that you're talking about, but the question might be, can you override the accessor method? And to that, the answer is yes. Does that answer the question? I'm going to assume yes. All right.
We'll find out.
Okay. So,
yes, it did.
Okay, excellent. So if you're using JSON for all of your JSON needs, unfortunately, the latest version 2.8.6 does not support records. And this is because records are always immutable, and JSON depends on reflection to be able to construct objects from JSON. So there's a way around that, and I'll show you how to do that. Not necessarily because I want to teach you how to work around the limitations of JSON, but more as a demonstration that there are reflection limitations with records, and you might need to work around that for any library that depends on it. So let's take a look at some code. All right, DTO test. So here I have my JSON string. I can declare inline this record that I know is going to conform to the string that I'm expecting. I declare my Jackson object mapper, and then I can call the read value method. Here's my string of JSON. There's the class that I want to read it into, and it's going to build this object just fine. We'll take a look at that in the debugger. There's a person I just built and has all the data that I expect. The parse is just great. Good job, Jackson. You did not let me down. So we mentioned before about the compact constructor and how this is always called by the canonical constructor. I'm going to set a breakpoint in here where I'm going to validate this input. So if the input is too long, this validation is going to fail, because clearly my record is called a short word. I want it to fail if it's not a short word. So let's see what happens when I ask Jackson to deserialize this string here. So I just kicked off the debugger. Jackson is going to try to read this. I'm telling it which class I want it to go into. Excuse me. Notice that Jackson did not use reflection to try to build this object. It called the actual constructor. It knows that this is a record. It knows it needs to use the constructor, and it calls that canonical constructor. So it comes into here, and this, of course, is detected to be an illegal argument, and it's going to throw an exception. Down here, Jackson is under the hood going to catch that exception and say, hey, I couldn't instantiate your value, and I'm going to throw a value instantiation exception. So I'm not going to see the illegal argument exception here. I'm going to see the exception that Jackson throws when it tries to process this. And of course, JUnit caught that, and it is working as expected. Let's take a look at what JSON looks like. I have, of course, the same string here. I have my JSON builder, and I construct my JSON object. If all you need to do is construct a string, JSON will work just fine. So if all you need to do is create a DTO and send it out of the server, you don't need to do any extra work because you don't have to construct any objects. There's no reflection necessary. JSON will see the fields, and it'll just grab them and output them into the appropriate strings. So you can see that it already did this just fine. There was no customization necessary. Now, if I step over, here's a part where it's going to get tricky. I have my input JSON string, the class that I want it to parse into. And when I step into that, all I have here are raw JSON element objects and some type information. So I, the programmer, am going to have to know what the input string is, what the types are, what the field names are that I expect, and I have to know how to call this constructor myself. So kind of a lot of work, especially if you have a lot of objects to work with. But it did pass. So it will work. You can do that and it'll work just fine. Serialization, just what some of you have been waiting for. So historically, serialization is unsafe because the way serialization works, unless you do a whole lot of extra work with customization, it just takes a whole bunch of bytes and says, I'm going to use reflection to take all these bytes and just turn it into an object. It doesn't do any checking. It is possible to create an impossible object. So, and there are a lot of security holes that come up over the years. It's just a well-known idea that Java's traditional serialization is not really that safe. But I'm here to tell you that records are serialized differently. Records serialization always goes through the constructor. It takes the bytes, treats them as data and data only, puts them through the canonical constructor. So all of your validation is run, everything is type safe, and it is impossible to build an impossible object if you're using serialization with records. You do still need to implement the serializable interface, but you don't need to specify a serial version UID. If you really want to get into versioning, there's more about that in the spec. We're not going to get into that tonight. But we are going to see serialization in action. So first of all, I have my file that I'm going to write a serialized record to. Let's kick off the debugger. So there's the file where it's going to. Here is my new point. This is a record class right here. I give it my two values. You can see that it hit the validation block here, as I would hope. I'm going to step through here. Here I'm writing it out to the file system. I call output.writeObject, and it wrote out to the file system. Now I'm going to read that back in. I'm going to read object, cast it as a point. And again, I read that off the disk, and the serialization mechanism went through the constructor, called the compact constructor, and is hitting this validation block. So here I have my original point before serialization. I serialized it and deserialized it and got back P2. And you can see that the data here is the same. Also, as a quick side note, this, what you see right here, point, square bracket, x equals 1.0, comma, y equals 2.0, square bracket. this is the default implementation of the toString method. So this is the kind of thing that you get for free when you use a record. So anyway, back to serialization. Everything's serialized and deserialized just fine. We're going to compare this with serialization with a traditional class. I have here a point class. I'm trying to make this as close to the record as I could. But yeah, so this has to be outside of the method because I can't declare static classes inside the method. And if it was inside the method and it was a non-static class, it would have a reference to the enclosing class, which is not serializable. It's just gonna be a big mess. So anyway, there's a whole story why this class is right here. So, but I do want to make it as much like a record as I can. So I have my variables, I declare my my constructor. I'm just kind of passing over the other methods for now, but you can see what's going on here. I have my class that contains the values. So I'm going to construct that class with the same data. You can see here, I hit the validation block here. That's just inside the normal constructor. Everything is normal so far so good. So I'm going to write this object to disk, and I'm going to read this back from the disk. Here, when I call read object, what do you think is going to happen? Is it going to hit the constructor or not? You don't have to answer, just answer in your own head. Use your inside voice. It does not. That validation block did not get hit because it did not use the constructor. It just took a bunch of bytes and said, I want it to be this class, and we use reflection to just build it. And so I could have gone in and modified that file to values that are invalid, and it would have happily constructed that. So that's one of the reasons why traditional serialization is really not that safe.
There's another question.
Okay.
Is there a way to mark a field as sensitive to keep it out of string representation, or do you have to re-implement toString?
Wait, are we talking about the serialization or the toString method? Can you repeat the question?
Is there a way to mark a field as sensitive or to keep it out of the string representation, or do you have to re-implement toString? I guess it's when they say string representation, they might be talking about serialization.
Okay. ToString and serialization are two different things here. Serialization is going to write it out to bytes. If I were to open up that file, see if this opens up.
Oh, I'm sorry. It says this isn't related to serialization, but it was triggered by showing the representation.
Okay. By showing the representation out in the debugger, where we looked at the said the class name and the x equals 1, y equals 2.
Mm-hmm.
ToString. Yeah, if you override ToString, which you can, then your implementation is what's going to show up down there in the debugger. I think IntelliJ, when it is running the debugger, it's just going to call ToString on whatever object it's showing you in the dialog here.
Cool. Neat.
Okay. Is the question answered? I presume yes. All right, let's move on. So, what's another data transfer object that we typically use? JPA. You can't talk about representing data in Java without talking about JPA. So when a lot of people, when they hear about records for the first time, they say, oh, immutable objects that carry data. I love immutable objects that carry data. I want my JPA entities to be a record. Unfortunately, records cannot be JPA entities because records don't satisfy the JPA spec. The JPA spec is all about state transitions, and being immutable, records cannot transition their state, so they really don't fit into the JPA entity. If you have an entity that has to be an entity, there are other ways to make it immutable. There's a hibernate immutable annotation, remove your setters, and that's about as close as you're going to get. But I want to show you a place where records will fit in, because records still have a home in your JPA world. If you have a projection, which is doing a select and getting a whole bunch of rows of data, you can project those into records, which become your DTOs that will be returned directly by Hibernate. So in that case, you've already mapped something to DTO, which sometimes when you're retrieving data, say for a web page, you want to map it to a DTO anyway. The result is already immutable, so that's a plus. And it can even be a little bit faster because there is a little bit of overhead with constructing and managing a set of JPA entities. So let's see what that can look like. So let's open up the JPA test. Now, I confess I'm not connecting to an actual database. This code is copied out of a side project that I was working with that actually it does connect to a database, and I can testify that this does work. You're just going to have to take my word for it. But the point is the code that we're going to look at. So let's take a look at my store repository here. So if you use Spring Data, this might look familiar. This is my repository standard data repository pattern. So I have my inferred query. This method will just say, hey, I want to make a query by name. What does my JPA entity look like? Here I have a JPA entity. I have a table name, it has a primary key, name and a website. You can imagine it could have all kinds of other data linked to it in here, maybe customers and items that are in stock and so on and so forth. But what does the store record look like? Maybe I want to use this to represent stores in a listing. And all I need is the name and website that I can click on. So I just need to make a link for a web page. So in that case, this is all I really need. So take a look at this syntax right here. And this doesn't have to be used with Spring Data. This can be used anywhere you would use JPQL, the Java Persistence Query Language. So you can say select new, fully qualified class name, and then this is my constructor. And then I pass in, and then I pass in the values that came out of my query from, in this case, from store S. Now, this is not a new thing. You could always do this with any class that has a constructor. But what I want to show you here is that records are a good place for this because you can, because it has a constructor and it's an immutable object and it's going to be returned directly by Hibernate once you execute this query. So this will come back just immediately. So I think that's pretty cool, and it's a place where records will fit into your JPA world. Are there any questions about that? Nope. Let's move on. So we all know and love maps, right? You have a map, it's a data structure, you give it two values, a key and a value, and then you can get that value back as long as you know what the key is. Sometimes you want to make something just a little bit more complicated and have the key be made up of two values or a map that has compound keys. So you can do this. You can write a wrapper class that will function as your compound map key. Now, when you do this, you do have to implement equals and hash code. That object needs to be immutable and consistent. Its hash code can't change. So, and not only do you have to write the code that will do that, you have to ask yourself, did you do it correctly? And then you also have to ask yourself, not only did you do it correctly, but did you do it efficiently? So we're going to see how records can really solve this problem for you. We'll first look at a non-record implementation and see what kinds of problems can come up when we try to do this ourselves. So imagine I'm writing a website with a server for a website that's managing employees from multiple companies. So I need two pieces of information to uniquely identify an employee. I need company ID and an employee ID. Those two pieces of information together are going to make the key into a piece of data that I want associated with that employee. So to bundle those two pieces of data, I have this class here called a custom map key. So it's pretty simple as far as classes go. I have my constructor, I follow the Java Bean patterns, implement equals and hash code, and I dust my hands and consider it done. So let's look through the debugger and see what this looks like as we step through. First, I'm going to construct these two keys, and I'm going to look at what the hash codes are for these two keys. You can see that they have the same hash code. Maybe a little bit surprising, but maybe not so surprising if you have sharp eyes and you happen to see how I implemented this custom map key, the hash code method. If you look back at the implementation, you see that the hash code just takes the two values that it has, concatenates them together, and returns the hash code. Now, that can work. It's not the best implementation, but it gives you a hash code, and you can use that to get values back out of your map. But you do have the possibility of a hash collision, so maybe not the best implementation. But this will do for now, so let's just run with it. I can get the value back out if I have the key. So assert not null, start dates.get key 1, that came back out just fine. Now, imagine, if you will, that further down in the code, maybe by another thread, someone modifies this object because it followed the Java bean pattern, and people tend to follow the Java bean pattern because reasons. So someone modified this, and this has a new value in it right now. What does the hash code look like after you modify it? The hash code has changed. Ask yourself, what happens to my map when the hash code of one of my keys changes? Again, use your inside voice. What happens is that the hash code changes. Now, when you try to use that key to get the value associated with it, the system is going to evaluate the hash code. It's going to try to use that to look up the key. And of course, the hash code, the key that's associated with the location of in memory with that hash code, if you think about the implementation of a hash map, that value is not going to be there. The system knows that the value is here. There are two objects in the map. I can tell that it's still there, but I can't get it back out because my hash code changed, because I accidentally used a mutable object for my key. So that's a problem. What would this look like if we used records? So for one thing, I didn't have to write all that code. That's a plus. But remember, records aren't necessarily here to keep you from writing code. It's a plus, and it's nice that I don't have to write it. But let's see why this becomes powerful. This is almost identical to the implementation I had in the previous method. Let's step through the debugger. So here's my record declaration. I declare my map using my record as the key. And you can see that I'm calculating the hash codes, and these are different. Even though these have the same company ID, employee ID that we saw before, I don't come to the same hash code like I did before. So presumably equals and hash code were implemented correctly and efficiently. So let's go ahead and put some values in here. Again, I can still tell that this map has two values in it, and I can get my values back out. Now, notice that nothing changed because I didn't call a setter, I didn't change the hash code. It's literally impossible to change the hash code of this compound key object because it is immutable, and it's strongly immutable. It's impossible to change. So an entire class of problems simply doesn't exist just because I used an immutable object. And it was easy for me to use an immutable object because I used records. Of course, you can make immutable objects without records. When something's easy to do, you're more likely to do it. And not only that, I'll give you one little last tidbit about compound map keys. Because equals and hash code are implemented consistently, all I need is, I don't even need the original object. Equals and hash code are calculated by the data only. So as long as I have these two pieces of data, company ID, employee ID, I can still get this value back out of the map. So that's it for compound map keys. Are there any questions for that? Okay. Let's talk about multiple return values. Always, when you return a value from a method, you can only return one thing at a time, right? There are common ways to get around this. If I say, hey, I actually want to return two things from this method. So there are a couple ways around that, a couple ways to bundle things together without records, some of them more elegant than others. But I want to show you what this could look like if we use records. So imagine I have some code here. It's my production code. and I have a method that computes some statistics, takes in some data, calculates some values, and I'm going to return all these values at once. I could just as well have all these 3 lines here, this code inline. It could just be right here. But because it's easy for me to do this, I'm more likely to do this. So that extracting this out into a method makes it easier to unit test. It indicates that not only that these values have been calculated. If this is in line, I could certainly calculate them down here, but the fact that I'm returning them here gives me extra indication that these values are intended to go together. They mean something together. And that's really the power of records, that it's easy to do this, and it's easy to indicate to the reader that these values belong together. This is a new, it's almost a new type here. So I can return all of this from a single method. And when it comes back here, if I have another method that I want to pass those values to, I don't need to declare a method with all of these parameters. I declare a method with one parameter. I can continue working with this because these values are intended to go together. So this is a really small and simple code demo, but I think this is actually possibly one of the most powerful points that I want to make in this entire presentation, that records have the potential to change how you write your code, to change the way you write your code in ways that are simpler and easier to understand and give you better names to reason about the code that you're writing. Probably not a lot of questions about this, but does anyone have questions or comments? Okay. Let's talk about streams. I love streams. It's one of my favorite subjects.
Oh, we have a question.
Okay.
Let's see here. Can these be written anonymously as a stream, accumulator, intermediate array, or return?
Wait, are you talking about streams or the previous demo? Did you say streams?
Yeah, someone is asking about stream. Oh, yeah. Is that coming up soon?
How about
he preempted your slides, so never mind.
How about I do the stream section, and then if the question's not answered, just throw the questions at me.
And there's a second question. Can records have? No. It says, can records have generic fields?
Yes, for sure. That was an easy one, and we'll see that.
Okay, so coming up.
Actually, we can use generics in the next demo that we're about to see.
Okay, cool.
All right, cool. So let's talk about streams. So check out my handy dandy stream picture here. So imagine your Java stream. Watch my little cursor. You can imagine objects coming through your stream. It comes in one side, comes out the other. Comes in, it might get filtered, comes in, and it might get mapped and come out the other side. Streams are really handy. There's a reason that they're relatively popular in Java 8. Sometimes I found myself, and you've probably found yourself too, I find myself wanting to use a map on the stream, but not just map it to one thing. I actually want to retain the original value, because the original value has something valuable to know about it. Maybe I want to consolidate them in some way in a later step. Possibly I want to use my terminal operation to construct a map from the input value and the output value of the map. So there is some value to being able to use a map and pass along the original value along with the value that you mapped to. So that's one use case of records that's easy to express two values bundled together. So that could be like your pair. There are other things that you can do with a stream in terms of objects that you want to use to process through a stream. You could use a record to express an either object. That would be like a pair, but it only has one value or the other. So an either is really a special case of a pair. You could also do something like a try, where a try is a special case of an either. A try could have either the result of evaluating a function or the exception that was thrown when you tried to evaluate that function. So there are some fun things you can do when you have the ability to just do something as simple as bundle two things together. it can change the way that you process data through your stream. Don't make it too complicated. It would be easy to go a little off the rails there, but I think it can give you some facilities to do things that you might want to do. So records afford you the opportunity to change how things flow through the stream. Now, records are also data carriers. So being data carriers, they make great targets for your terminal operation because you need something to carry the data that's resulting from that stream. So we'll see that in action too in the code sample. We'll use reducing and teeing and use a record as the target for that terminal operation to put our data into. All right, so here is our stream test. So I have a list of strings, pretty easy to reason about there. As of Java 10 introduced local variable type inference. And with local variable type inference, you can subclass object, and this type information is retained. If I were to step through this in the debugger, when I get to this breakpoint, you would see that the elements in here do have all of the type information in here. Let's take a look. I have the original value that came through, a processed value, and some metadata that I also introduced along the way. The type information is retained. So this is valid as of Java 10. Admittedly, it's a little bit awkward. And it doesn't have a name. It's just this weird anonymous type without a name, the type that shall not be named. So you can do it, but there's a better way. Here I have a record that I'm declaring inline, and it has an input value, an output value, and that metadata that I just want to happen to store along with it. So this record replaces the subclassing of this object. And this line, the creation of this record, replaces this block of code right here. And I think this is not quite as readable as this. I think this is definitely a lot easier to reason about. It's easier to give it a name. It's not an anonymous type. You can say, oh, when it goes to my processed word. So it's easier to talk about. You can point at it. You can give it a name. You can talk about it. It just makes a lot more sense. And it's easier to read. This happens in one line. And you can see, of course, just as we would hope, the type information is retained because it's its own type. All right. Any questions about that? The stream samples are a little bit longer, so I'll break after each one. All right, let's talk about targeting terminal operations. So I have here a charge record. It has two values bundled together and a list of itemized charges. Maybe I'm doing bill processing for a hotel, and these are the itemized charges from my hotel bill. So if I step this through the debugger, we'll see that these itemized charges I'm streaming through, I have a list of charges. So they make good data carriers. So I just have a list here to start with. As I stream through, I want to say, hey, I have a list of charges. I want to get the total of just all the charges and just the total tax of all the charges. So I can stream through all these. Here's a place where the generated method kind of works a little bit better as a method reference. I don't have charge : get amount. It's just charge amount. So maybe a little bit more readable. That's kind of nice. I can reduce it and get the total amount. I can do a map reduce and get the total tax. And this has the values that I would expect down here. Now, the downside to that is that I did have to stream through them twice. The other downside is that if I didn't really give these good names, by the time you get further down in the code, it might not be totally clear that these values actually relate to each other. They relate to each other in a very special way. It's the total amount and the total tax for all the charges that we were working with here. But by the time you get down here, you just have two values just hanging out. There's no way to tell that they are intended to be related to each other. So let's see what we can do with this. I can take these itemized charges, stream through them again, and I'm going to use this add method. This add method that I added to my charge record just takes a charge, adds its amount and tax to the existing one, and returns a brand new object right here. So with this add method, I can use that in my reduce operation. So I have my starter value. As objects come through the stream, I'm going to reduce them with my add method here. And then all the amounts will be added together, all the taxes will be added together, and I will have a single object at the end with all of my totals. So the value here is I didn't have to stream through it twice. The other value is that these values are clearly indicated to belong together. I have a charge total, and the amount and the tax are connected through this record. So that's how to use a record for your terminal operation. I'm going to also demonstrate another terminal operation with teeing. Teeing is a little less common, so I'll give this a word of explanation. Teeing is a stream method. It's a very special collector that itself takes two collectors. Here's one collector. Here's another collector. And it'll take the results of these two collectors and pass them into this finishing function that takes two values. Those two values are going to be the results of these two collectors. So here I'm using the summing double collector, which just returns a double. And so all of the objects, all of these charge objects are going to go into this collector. And then those same objects will also be passed into this collector. This object, the stream is going to split essentially. So it goes, charges go into here, sums the amounts, charges go into here, sums the taxes, and then those sums go into this new charge object. And then I get my charge 2 down here. So we would expect this to look the same as the first one, and it does. So maybe a little bit more complicated, but if you do it that way, then you don't have to write this add method right here. Any questions about that?
Let me see here. There's one question. Will you show the either or try example implemented with records?
I will. That's the very next one.
Oh, okay. So did the question, can these be written anonymously as a stream accumulator, intermediary, or return? Mike, do you feel that question has been answered?
Can you repeat the question?
The previous question that Mike asked, can these be written anonymously as a stream accumulator, intermediary, or return? I think I see like there's like reduced here. I don't know. Does that answer Mike's question?
Can you write it as an intermediate? I mean, you can map if you're talking about an intermediate, I guess that would be the map.
I think what Mike's asking, and maybe he can add a chat if this is the case, is can you have anonymous records? Could you create an anonymous record in the context of a stream operation without having to give the record a class name?
Oh, I don't believe so. I haven't heard of any notion of an anonymous record. I think the best you can do is to say, in advance of your stream, to say, hey, here's a record, this thing with my record components. So it's just one line, but there's no, I'm not sure what an anonymous record would really look like. Usually when I think anonymous, I think of like an anonymous subclass where you declare the subclass and then it has a type, but it's an anonymous type. Record types are never anonymous because you can't have an anonymous subclass of a record. Does that make sense? Maybe I'm misunderstanding the question, but I'm not sure.
I think that's good for now. We'll hash it out in the chat. Oh yeah, Mike says we got it. That's good. Thank you.
Excellent. All right.
Okay, and then the either or try. Okay.
That's coming up next. So I'm glad someone was excited to hear about that because I didn't know if this was overkill or not. But I think what we're going to see here is we're kind of get a 2-for-1 deal out of this. We're going to see records used as intermediate values in a stream, records used as accumulators for your terminal operation. We're going to see generics, and we're going to see how to handle checked exceptions in streams. Excited about that? I'm excited about that. If only we were in person, I would be hoping to hear people cheering and yelling, because isn't this the problem that we've all faced? Checked exceptions in streams. What do you even do with that? So let's talk about, I'm getting a little feedback. Is it? Okay, cool, thank you. So here is a simple date format. I think I'm still getting some feedback.
Oh, sorry.
All right, is it still on? All right, that's much better. Thank you. So, simple date format. This is a class that Java provides to us, and I can tell it what I want the format to be. Now, let's say that I have a list of data coming in here. Which one won't be parsed? I'm not sure. Maybe this one. So, oftentimes what we do when we have unchecked, imagine if we have, let's start simple. We have a stream and there are unchecked exceptions thrown. One common approach is to say, hey, the stream is really cheap, the input data was really cheap, I don't care. Just if there's an exception, just abandon the whole thing. Just get out of here and throw away everything and just say, hey, I couldn't do it. The next level up is if you need to handle a checked exception. This is one thing you can do, and I've used this before outside the context of records or anything. If you're using a third party or code that you don't have control over, you can't really change the signature of this method. You can't tell it not to throw an exception. So I have this little utility called uncheck, and this is a higher order function. It takes a function that throws a checked exception and returns a function that throws unchecked exceptions, if that makes sense. So the result of this little highlighted block here is a method reference that does not throw a checked exception. This allows me to embed this method reference inside of my stream. I'll let you see what this looks like. Here's my uncheck. So again, this is a higher order function, takes a function that throws a checked exception, and it tries to evaluate the method. It returns this function right here. So it returns a function that throws an unchecked exception. So if you try to run this, you'll see that this stream runs through. It'll try to evaluate it, and it's going to throw this unchecked exception, and then just throw up its hands and say, hey, I got an exception here. Nothing I can do about that. I got a bad batch. Just abandon the whole thing. So if your input data is cheap or you don't care, then it's maybe not a bad approach. But what if it's data that comes in from request and you only get one shot at it and you don't want to just throw everything away? You might need a more subtle approach. So I'm going to introduce a new concept here. This is similar to the uncheck higher order function that we saw before, but instead of taking this function that throws a checked exception, it's going to take a function that throws a checked exception and return a function that takes the function. Let me see if I can talk through this. It returns a function that returns a try, where the try has either the result of evaluating the function or the exception that was thrown in the attempt to evaluate that function. Maybe it'll make more sense if we can see it here. So here's the checked exception, and I'm going to the function that throws the checked exception, and I'm going to return a function that attempts to evaluate it, and if it succeeds, the returned function from the higher order function returns a try that has the result. And if it throws an exception, it returns a try that has the exception. Higher order function takes a function, returns a function. Is everyone with me so far? It's hard to tell without nodding heads or furrowed brows how well this is going over, but I'll just keep moving and just jump in if anyone needs something repeated. So we're going to stream through this and look at our try objects here. Oh, I'll show you also what that try object even looks like. Try here is a record, and this is the generics that everyone's been asking about. So this can be a try where the generic here is the value of the return value of the function that you're attempting. And then this doesn't have to use generics because it can just take any exception. So this is the generic ability here in the record. Oh, and also this is the either mechanism. So this is going to validate once you call the canonical constructor for try, the compacted constructor is going to validate that you've only given it one or the other. It has to be one or the other. You can't be both. So let's step through this. So I have now my list of tries. You can see here, I have a result here, but I did catch that parse exception. I have the actual exception right here. So everything that was possible to be processed was processed. Everything that could not be processed is still here, and I have the details on that right here. So similarly to what I did in the charge demo up here, you can go through the stream and extract the values that you want independently. But that might not be quite optimal because, again, you have to stream through these twice. And these values are now disconnected. There is no association later on in the code that these successes are related to, like, these exceptions were the failures, where these successes were the successes. So there's a better approach. Here, this is the grand finale for streams. Stay with me. We're going to higher order function, pass in the function that throws checked exception, return a function that returns the try object. So I have an intermediate object here, which is a record. So that's the try object that's going to come through. And I'm also going to have this record as the collector for my terminal operation. So I'm going to use teeing. I have two different collectors here. Remember how teeing works. Teeing takes two collectors. This collector takes a stream of tries and will extract a list of results. This collector takes a stream of tries and returns a list of exceptions. And then this constructor, this record that's going to be my data carrying record, is going to take a list of results and a list of exceptions. You can see I'm matching the generic here. This is the generic for my results. So let's step through. Now I have my results and exceptions. Let's look at this in the debugger. I have two results. Now notice these are still connected together. I have my results and exceptions record here. These are connected. I know that when I attempted to process that batch, these are the ones that passed. This is the one that failed. And of course I could put whatever data I want to in here, maybe the original value or other metadata that were in play at the time that this process was happening. But there you have it. We used records. We solved the stream problem. I won't say we solved the stream problem. This is kind of a first pass at solving the stream problem. But we used records. We used a try, which is a special case of an either, which is a special case of a pair. We solved the try problem, the stream problem, and we collected it into another record. And I think it came out pretty well. Are there any questions about this, or is there anything that anyone wants to see stepped through the debugger again? Does anyone want to see the try object again?
Let me see here. Dan M, did Jason answer your question? But the try example, yeah, he showed that. Okay. Someone asked about what teeing does.
Okay, I can explain teeing again. You can. I'll run through it again. If it still doesn't make sense, you can find the Java doc for it.
Or
it's not super simple, but
Okay.
I'll at least give it another run through.
Okay.
Teeing is a terminal, well, collect is technically the terminal operation of the stream. So teeing is a collector that itself takes two collectors and a method that takes the result of those two collectors. So here I have teeing. Now imagine I have a stream. After this map evaluates, I have a stream of try objects. The try object has either the result of evaluating the function or the exception that was thrown as a result of trying to evaluate that function. So at this point, I have a stream of tries coming in. So here I have two collectors. This is a collector that takes all of the try objects. This is a collector that also takes all the try objects. The stream splits and the tries go into both of these. And each object is going to go into this one and into this one. This is going to filter through those objects. And if it's a try that has the result, it's going to put it into a list. And if this is a try that has the exception, it's going to put it into a list. And then my results and exceptions record here takes two lists, a list of results or a list of exceptions. This could be any function you want, really. But in this case, it's convenient for it to be the constructor, because that's going to be the data carrier that takes the results of these two collectors. And because I'm using teeing, this is itself, this is the real collector. This is kind of a wrapping collector, as it will. So all the tries come into here, and this takes all those try objects and it's going to funnel them through this, and collect them into this wrapping record that's going to keep the results for me. I hope that made more sense. Teeing is not super easy, but it's worth a look. It's worth knowing about, I think. I don't use it all the time, but yeah, it's a good tool to have in your tool belt because you might need it. Are there other questions?
There's also basically, could I define a record inside of the stream?
Could you define a record inside of the stream?
Yeah.
Let's see, I'm going to do something like this. I have not tried this before, so this is highly experimental, but this is the whole point why I have my IDE up for us to be able to try something out like this. Let's try it out. I'm going to try to do something inline in here. Record, try to. What about that? Is that going to work? Oh wait, T goes to, so I declare a record. My record name is try to. Oh, you know what? That conflicts with that. So I'm going to declare a record. That should be safe. I'm going to return new try to. Aha! Like this? Is this what they're asking about? But you see what I'm trying to do, right? I'm trying to declare a record inline inside the stream, and I want to wrap it. I want to wrap my try object in that, and then I just want to unwrap it just so it doesn't do anything. I'd have to mess around with it. Prototype, provide object.
It looks like he's asking about, could I define a record? I don't know if Mike is asking actually defining the record instead of just declaring it.
I'm not sure what difference you mean. Defining and declaring to me means the same thing for a record.
Okay. Okay.
Jean, why don't we mark that question answered, and if Mike wants to clarify, he can ask a new one.
Okay, thanks. And what another question? If two results and two exceptions are collected separately, is that the question? Is that in reference to your previous question?
Are you asking me, or are you waiting?
No, okay. Part of your previous question. Okay. Let's see here. I'm gonna look back at. Okay. For teeing, is your question if two results and two exceptions are collected separately in teeing? Is that your question? Sharon? Okay, I'm not exactly sure what the question is.
Okay. Do you want to?
Also, if someone else asked how the 76ers will go in the playoffs.
Unfortunately, I don't have an answer to that. So we just want to just move on?
Yeah.
Okay.
Okay.
All right, this is the last demo of the night. So let's talk about tree nodes and abstract syntax trees. Records do make a good fit into here because trees are data structures and records are good data carriers, so they fit in with your data structures. I'm also going to demonstrate how records fit in with sealed classes, which is also a new language feature. So imagine that you have a mathematical expression that you need to parse and evaluate. If you were to evaluate this expression into a tree node, you might say, well, this 5 plus 4 evaluates into a small tree with a plus at the top and a 5 and a 4 on each side. And then if you want to subtract 1, then you would have a subtraction node right here, and then 1 on the other side. Whoops, that should actually be a 1 right there. A little bit misleading. So this mathematical expression corresponds to this tree data structure. We've probably worked with things like this before. So how could we express this with records? Let's take a look at an expression interface. So I have interface expression. It defines one method called value. Now here is where we have some new syntax here. We have this sealed concept. So sealed and permits. A sealed class can only be extended by the subclasses that are permitted after the permits word. A sealed interface can only be extended or implemented by the interfaces or the classes that follow the permits word here. So sealed and permits. This provides us algebraic data types. You can Google it and spend the rest of the night reading up on algebraic data types. But in sum, this controls the extendability of your class or interface and says nothing else is allowed to extend or implement this interface other than what I've listed out right here. So back to the interface, I have an interface and a single method. Here I have a record that implements this interface. In this case, my record component has the name that will let it generate the method for this interface. So that I can implement this interface, but I don't need to declare the method, it's generated for me. So this is a good example of a record implementing an interface. Here I have another record also implementing an interface. This is the one that I have up here. So I'm allowed to implement it because it's in my permits section. So you can see I have an add expression. It just takes the left-hand side, right-hand side, adds them together, no surprises. Same thing for my subtract expression. Implements expression, I'm allowed to because it's in my permits section, and just takes two values and subtracts one from the other. So I can use records inside my interface and have everything all in one file, all contained in one interface. So if we were to go back to my test here, I could evaluate this. We have an expression with a constant, expression with a constant. I build this up. Sorry, I didn't write a parser for you. I hope that's okay. And we have our root is going to be the minus up here. And if I were to go ahead and evaluate this, we would see that it does evaluate to the value that we would expect. 5 plus 4, quantity minus 1 equals 8. So that's it for records with interfaces and sealed interfaces and abstract syntax trees. So yeah, records make good nodes because they're immutable and they're easy to define and easy to build. So, are there any questions on that? No questions on sealed interfaces?
Not right now.
Okay. Let's move on. That's it for the code demos. So let's talk about migrating to records. Now that everyone's really excited about records, and you cannot wait to get this into your own code, how do you migrate to records? So fortunately, like I said in the beginning, records work a lot like classes. In fact, they compile to essentially classes. So they're really easy to use. They lend themselves to mixing and matching because they work together with existing code so well. Good news for you is that record is not a keyword. So you can have an int named record, totally legal. You can have a method named record, also totally legal. One thing that you might encounter is that if you have an existing record class in your code base, it's called record. Java lang record is always automatically imported because the Java lang package is always imported. So you could have a conflict on a wildcard import. So something that could come up, but you'll probably catch it pretty quickly. Some that you might catch less quickly is the change in the equals method. So this is a really important point. If you don't implement equals, you don't implement a data-based equals for your data carriers, the default implementation of an object is reference equality. If two objects are compared to be at the same location in memory, they're considered equal. That's the default implementation. With a record, if you have two records, they are considered equal if their data is the same. It will call equals on the data values inside of it. So if you just take an existing data carrier and you haven't implemented a data-based equals method for it, you depend on the reference-based equals method, the behavior is going to change. And that can be a very subtle bug that you'd have to hunt around for until you can find it. So this is something to be aware of and to watch out for as you start to migrate to records, if your records are going to participate in things like collections and maps. So that's a couple words about migrating to records. And I want to say now, in conclusion, I don't want anyone to think that I'm rolling in and saying I'm bad-mouthing classes. Classes are old news. Everyone should transition to the records. Not what I'm saying at all. Classes are still absolutely necessary for a whole ton of things. Classes participate in inheritance hierarchies. Classes can fulfill the Java Bean convention. Classes can be JPA entities. You absolutely still need to have classes. But what I want to do here tonight is to show you that records, this new feature, do things and let you do things that you might not have done before. And I think that's pretty exciting. And I hope that you find that pretty exciting too. So that's it for tonight. Are there any final questions? Anything record related? No?
don't see any new questions.
Okay.
Well, there's one in the chat. Do you have this code base in GitHub?
Yes. When the slides go out, actually, let me go back to the very beginning. I'll post this in the chat. Let's see, it's in this one. Whoops. So this is my generic Java demo section. So you can download that and look at everything in there. Not super cleaned up yet. I just kind of experiment in here, but it's this is the best part of this particular repo is the code that we just saw. So there it is. Any other questions?
So another question in the Q&A is: are there other future expansions of records planned?
There could be. The two things that come to mind are deconstruction. You could see that with pattern matching. So you could say, like, here, I want to do some pattern matching, and I want to extract the components, the record components of this record into these values as I do my pattern match. And then if it passes, then those values are immediately available to you. So you could see something with pattern matching, with deconstruction, and like was mentioned earlier, functional transformations. So it's still kind of in design. It's not even planned for Java 17 as far as I've seen yet. But yeah, we are still talking about how Java records are going to move forward into the future. So yes. Is that it?
I see one more now. What is the behavior of records when used in threads?
I expect them to be thread safe. They're immutable. The behavior will be the same as with any other object in a thread, except that it's immutable and probably much safer. So if you're dealing with multi-threaded code, I think that records are going to be a really good fit there.
Yeah, and from the functional programming perspective, like, absolutely, immutable objects are guaranteed thread safe. You know, if you don't no synchronization, you don't have to do anything. It's going to work.
Yep. All right. Anything else? I think we about got it covered.
Okay, the winners are noted in the spreadsheet if you want to check that.
All right. Well, thanks everyone for coming. I was super excited to present all this stuff to everyone. Hope you find it exciting, and I hope you find it a lot of fun.